Okay, let's step into one of the most intense, high-stakes environments in any hospital.
The operating room.
Exactly. The OR. It's truly the epicenter, right? A place where incredible complexity is just the baseline. Think about everything that has to line up perfectly.
You've got schedules, surgeons, staff.
Right, making sure the right, highly specialized equipment is available exactly when needed.
And then catering to the unique needs of each individual patient.
All while time is ticking, the pressure's high.
Yeah, absolutely.
And you know what? Even with all that meticulous planning, things still go sideways pretty often.
Oh, yeah. Delays are common.
Frustrating delays that just cascade through the whole day.
Surgeries get canceled.
Sometimes even at the last minute, right?
Right.
Like right before the patient is wheeled in.
It happens. And all this chaos often pushes dedicated staff into, well, excessive, exhausting overtime.
And our sources are really clear on this. These kinds of inefficiencies aren't just frustrating.
No, they cost.
They cost healthcare institutions millions, potentially even billions, every single year.
A huge financial drain.
But there's a powerful new player stepping into this complex, high-pressure arena.
That's right. AI is starting to make its way in.
Yeah.
And what's really fascinating, I think, is this isn't some far-off futuristic idea.
Right, it's happening now.
The material we've been diving into for this deep dive explores how artificial intelligence and machine learning are already being put to work.
Specifically to tackle these problems.
Exactly. Improving surgical planning, optimizing things before the patient even gets near the OR, and just smarter allocation of vital resources.
Okay, so our mission today is to really unpack what these sources are telling us.
Yeah, how exactly is AI aiming to make the OR run, well, significantly more smoothly?
We'll try to pull out some surprising facts, some insights.
And get a solid grasp on the potential ripple effects, right? On costs, efficiency.
And most importantly, on patient care. The quality, the experience.
Absolutely.
So we've got a stack of research papers here, expert analyses. Should give us a pretty comprehensive look at the state of play.
It's quite a bit of material.
Okay, let's dive in then. Starting with the fundamental challenge AI is trying to solve here.
Okay, so the core problem, according to the research we looked at, really boils down to surgical time estimates.
How long a surgery will actually take.
Right, and these estimates, often based on, subjective experience or just general averages, they can be shockingly inaccurate.
How inaccurate are we talking?
Well, one paper highlighted they can be off by as much as 50%. 50%.
Wow. Just imagine trying to run a complex operation like the OR schedule when your estimates are potentially half wrong.
Exactly. And that inaccuracy creates this cascade of problems, throughout the entire preoperative process.
So if you can't predict how long a case will truly take,
you end up with high cancellation rates, especially those really disruptive day of cancellation.
Air muscle lift drive up costs.
Oh, definitely. Drives up overtime costs for staff. It reduces the number of patients you can actually get through the OR in a day or throughput.
And I bet it affects patients too.
It can, yeah. Negatively impacts patient satisfaction because of unexpected delays or cancellations. Nobody likes that.
No. So it's just this constant uphill battle for OR management.
Incredibly stressful and expensive.
Yeah. We saw mentions of surgical backlogs too, like in orthopedics after the pandemic.
Those got worse.
Made significantly worse simply by these scheduling inefficiencies.
Which brings us to where AI and machine learning step in.
Okay.
So machine learning, ML, these are computational techniques designed to learn patterns and make predictions directly from data.
Without needing explicit programming for every single rule.
Precisely. And AI, artificial intelligence, is the broader field that includes ML. What's notable is that integrating AI and ML into OR management isn't just recent buzz.
It's been building.
Yeah, it's been steadily growing, really shifting from academic theory to actual practical application in hospitals since, say, around 2015.
And why now? What's the enabling factor?
Well, the reason this is even possible and why there's such immense potential lies in the sheer volume of healthcare data available today.
Right, the data explosion.
Mountains of information. Everything from detailed patient demographics, their full medical and surgical histories.
Specifics about anesthesia protocols used during procedures.
Even data from how patients recover afterwards in the recovery room.
So ML algorithms can use all that.
They're uniquely equipped to leverage this rich, complex data to tackle those exact challenges we just talked about, predicting surgical durations more accurately, optimizing those incredibly intricate schedules, making smarter decisions about resource use.
Okay. And when you look at the research and the sources, it's striking how much focuses on predicting that surgical duration.
It really is. One review we saw found that 17 out of 22 papers specifically tackled this problem.
Wow.
It just underscores how fundamental an accurate time estimate is for everything else in OR management.
It's crucial for efficiency, right? Reducing wasted time, rooms sitting empty.
Exactly, and ultimately getting patients through the system more effectively.
So what kind of improvements are they actually seeing?
Well, the papers provide some pretty compelling numbers on the accuracy improvements with these ML models compared to, the traditional ways.
Better than experienced schedulers.
Some models are achieving accuracy rates over 75% in predicting duration. So yeah, performing as well as or even better than them.
That's significant.
And what's maybe even more impressive is the improvement in predicting cases within a tighter time frame, say within a 10% variation of the actual time.
Yeah.
Using older standard institutional methods, accuracy for that kind of tight window might be around maybe 32%.
Right.
With ML models, studies show that jumping to 39%, and some models are even hitting up to 50% accuracy within that narrow 10% window.
So much more precise.
Much more precise. And diving a bit deeper into the types of models, recent studies seem to favor algorithms like XGBoost, finding they outperform others, like random forests or linear regression for this specific task. Bag trees also showed strong performance, lower error rates.
Interesting.
And another key insight from the sources is the value of granularity. Getting specific.
How so?
They found that models trained to predict duration for specific individual surgeons.
Not just the type of surgery.
Exactly. Those surgeon-specific models were significantly more accurate than models trained just on the surgical service as a whole, like general surgery or orthopedics.
That makes perfect sense. I mean, every surgeon has their own nuances, their own pace.
Precisely. That level of detail really makes a difference.
We saw a great real-world example of this from Klinikum Stuttgart.
Oh, yeah.
They were using a solution called Torin or management. Now, even with their existing standard values, they had an average deviation of planned versus actual time of about 19 minutes.
Which is already pretty decent.
Pretty decent, yeah. But by adding AI analysis that looked at 27 different variables influencing duration.
They could shrink that deviation even further.
Exactly. It shows how AI can refine systems that are already working reasonably well.
And the prediction isn't just limited to the total time a surgery will take, right?
Yep, there was more.
One study introduced this interesting concept called modular artificial neural networks, or MNNs.
Okay, MANNNs. What do they do?
These models were designed to predict the remaining surgical duration.
While the surgery is happening.
Yeah, while the procedure is actually in progress. They found these MANNs outperform traditional statistical approaches, especially improving prediction accuracy in the later stages of surgery.
That's fascinating. So you could make real-time adjustments during the day based on updated predictions.
Potentially, yeah. It opens up possibilities for dynamic real-time adjustments.
Yeah. But AI's role isn't confined just to predicting how long a procedure will last, is it?
No, not at all. It's also being applied to optimize resource allocation much more broadly across the entire perioperative environment.
Like what kind of resources?
Well, things like predictive queue management and real-time monitoring systems. These use AI to forecast patient arrival patterns, potential wait times.
Letting staff be more proactive.
Exactly. Giving them the ability to proactively manage patient flow and hopefully head off bottlenecks before they even start.
And what about staffing? That's always complex.
Oh, absolutely. AI can really help there by predicting patient volumes and how complex their cases might be.
The acuity. Yeah.
Right. The system can assist in matching the right staff skills to the anticipated needs. The goal is ensuring hospitals are adequately staffed.
Which improves efficiency, but also.
It can also help combat staff burnout, which is often made worse by that unexpected overtime.
That makes sense. What else? Bed management.
Yep, that too. Predictive modeling can help reduce patient wait times for a hospital bed after their surgery.
And the potential impact there.
Sources suggest AI could help increase overall bed utilization by a significant amount. We saw figures ranging from 10% to maybe 15%.
So when you tie all these pieces together, optimizing scheduling, predicting duration accurately, smarter resource allocation.
Driven by these AI tools.
Hospitals are directly impacting those crucial performance indicators we talked about earlier.
Right. Lowering cancellation rates, increasing patient throughput, reducing that costly overtime.
It's all interconnected. It sounds like moving from reactive problem solving to more proactive management.
That's the goal. Proactive orchestration instead of reactive chaos.
Okay, shifting gears slightly. AI, also seems to have a role in enhancing workflow and decision support within the OR team itself.
Yeah, absolutely. The sources highlight the potential of large language models, or LLMs here.
LLMs, like ChatGPT and similar tech.
Exactly. They can potentially improve communication and coordination. Think about how critical that is in a fast-paced, high-pressure environment, especially with new team members rotating through.
Miscommunication can lead to delays, even errors.
Precisely. So better communication can directly reduce those issues. LLMs could help streamline complex workflows and improve consistency in care.
That's really interesting. How would an LLM specifically help with, say, workflow in that setting?
Well, one key area is potentially speeding up the learning curve for new staff.
How?
An LLM could provide tailored tutorials, maybe step-by-step procedural guides, or even real-time guidance during a procedure based on established best practices.
Like having an intelligent assistant on hand.
Kind of, yeah. An accessible knowledge base providing assistance right on the spot.
What about decision support?
They could contribute there, too, by integrating and synthesizing clinical insights. Some sources discussed potentially using audio data from expert surgeons' procedures.
Listening to the experts.
You're right, to build models that could then guide decisions for other teams, helping them achieve similarly cost-effective and time-effective outcomes.
And documentation. That's always a huge task.
Huge and often very time-consuming. The sources suggest LLMs could significantly assist here.
How? By automatically recording things.
Yeah, automatically and meticulously recording the sequence of events, any deviations from standard protocols, key decision points made throughout a procedure.
Wow. That level of detail.
It isn't just for admin. It provides really rich data that can be analyzed later to identify specific areas for process improvement.
Could help with training, too.
Inform targeted training programs, definitely. And it could even be crucial in addressing potential liability concerns.
By having a clear record.
Exactly, providing a clear, objective record of exactly what happened. The sources noted that while this transparency might theoretically lead to more questions from patients,
it also provides a strong defense.
A robust defense for healthcare providers by offering that detailed, objective account. And it could potentially build trust with patients, too, giving them a clearer picture of their care.
Okay, now, while all these potential benefits sound incredibly exciting, significant, it's really important to acknowledge the hurdles, right? Widespread adoption isn't straightforward.
No, not at all. There are substantial hurdles. One major challenge that came up consistently in the sources is, well, physician hesitancy.
Building digital trust, you called it.
Yeah, or building digital trust within the whole clinical team. Several factors contribute to this.
Like what?
Well, the complex, sometimes black box nature of AI systems, it's not always clear why an AI made a certain recommendation.
Which makes doctors uneasy.
Understandably. Concerns about potential risks to patient safety if an AI tool fails or is inaccurate. Questions about generalizability. Will findings from controlled studies really apply in the messy reality of a busy hospital?
And just basic familiarity.
Often, yeah. A simple lack of familiarity, training, and understanding among staff about how these algorithms actually work and how best to use them.
So education is key.
Absolutely essential, the research emphasizes. Training and education to bridge that gap.
And alongside the technical and trust challenges, there are critical ethical considerations.
Huge ones. The sources are clear these must be addressed proactively. They discuss how the foundational principles guiding surgical ethics,
like doing good, avoiding harm,
beneficence, non-maleficence, respecting patient autonomy, and ensuring justice or fairness, how they all apply directly when you start using AI in patient care.
So what are the specific ethical issues raised?
Okay, several key ones. Data privacy is paramount, especially with all the sensitive patient information regulations like Ep081 are critical guardrails.
And there's bias.
A very real risk. Bias entering the system, either from the data used to train the AI or within the algorithm itself, that could lead to inequities in care.
We need to understand the AI's reasoning, too.
Exactly. Ensuring transparency and explainability, knowing why the AI made a certain recommendation is vital, particularly when patient outcomes are on the line.
Accountability is tricky, too.
Defining clear accountability for errors when AI is involved is a complex question. Then there's cybersecurity, a constant concern.
And patient consent.
Ensuring true informed consent about the use of AI tools in a patient's care is an evolving area needing careful thought. The consensus in the material is clear. You need a stringent ethical approach and a culture of accountability right from the start.
Okay, and beyond ethics, there are just practical implementation hurdles.
Oh yeah, very practical ones. Getting high-quality standardized data into a usable format for AI is a major undertaking. Lots of data cleaning, preparation.
Integrating with existing hospital systems
Can be a real headache. Integrating new AI tools with complex, often decades-old legacy IT systems.
and it requires ongoing investment.
Definitely. Ongoing investment in computing power, skilled personnel to maintain these systems, retrain the models. One source suggested models might need retraining maybe quarterly to keep up.
Wow.
And finally, just ensuring user adoption. Providing effective training is crucial. A powerful AI tool is useless if the staff can't or won't use it effectively.
Right, but let's circle back to the bigger picture, because despite all those hurdles, the potential benefits AI could bring to healthcare overall are, well, massive.
Truly massive. The sources estimate potential cost savings across U.S. healthcare spending could range from 5% to 10%.
Which translates to
A staggering $200 billion to $360 billion annually. And optimizing complex, high-cost areas like the OR would contribute substantially to those savings, including reducing administrative costs tied up in dealing with all those inefficiencies.
And it's not just about the money saved.
No, definitely not. The sources emphasize equally important non-financial benefits.
Like patient outcomes.
Improved patient outcomes, significantly reduced patient wait times. One randomized clinical trial showed how ML predictions reduced prediction errors, which directly led to shorter patient waits without making surgeons wait longer.
Better patient satisfaction, too.
Increased patient satisfaction scores, yeah. And better regulated working hours for staff, helping to alleviate that burnout we discussed earlier.
So ultimately, the way the sources frame it, AI isn't about replacing people.
Not at all. It's not about replacing the incredible expertise of human surgeons and OR teams. It's framed as a powerful tool designed to augment that expertise.
To help them work smarter.
Exactly. Using AI to help shift from what can often feel like reactive chaos to more proactive, intelligent orchestration. Freeing up highly skilled clinicians and staff to focus their energy and attention where it matters most.
On providing the best possible patient care.
Rather than wrestling with inefficient systems.
Yeah.
Yeah.
So to wrap up this deep dive, we've seen how AI, particularly through its ability to accurately predict surgical duration and optimize a whole range of resources, holds really immense potential. It could fundamentally transform surgical planning and make operating rooms dramatically more efficient, more effective.
Right. It's clearly a future filled with tremendous opportunity, but one that absolutely requires careful navigation through those significant technical, ethical, and practical implementation challenges we talked about. It's a balancing act.
Definitely. So, considering all the potential upsides we've explored, the benefits in efficiency, the improvements in patient outcomes, and even the positive impact on staff well-being, what do you think is the single most crucial step healthcare systems need to prioritize right now to responsibly unlock the full potential of AI in the operating room?